If global industries continue operating exactly as they do today, climate models project a very specific baseline for the year 2050. It involves sea levels rising fast enough to overtake modern coastal infrastructure. That rising water would displace roughly 150 million people from coastal cities within decades, pushing the ocean into historic spaces we once thought were permanent. Inland, the heat intensifies. Megadroughts and soaring temperatures would render massive stretches of the tropics biologically uninhabitable for human life. This sequence of mass displacement and biodiversity collapse is the mathematical output of our current trajectory. Unless we drastically alter our industrial carbon footprint, this is where human history leads. We have physical proof that we can alter that trajectory overnight. In early 2020, the COVID-19 pandemic forced human activity to a sudden halt. Global supply chains paused. Heavy manufacturing abruptly ground to a standstill, and commercial aviation fleets were parked on the tarmac. This chart shows the immediate environmental side effect of that lockdown. In just months, China's carbon emissions plummeted by 25%. We cannot rely on a global pandemic to fix the atmosphere. The challenge is maintaining that low baseline while allowing the economy to function. But those lockdown months provided empirical proof for a crucial concept. Our massive carbon footprint is a variable, not a fixed law of nature. When the virus hit, the global scientific community shifted immediately into a mode of emergency science. Labs that used to compete for funding started dumping raw data onto open-source servers. Researchers published viral genomes for the world to see, and cross-border teams accelerated vaccine development to a fraction of the usual timeline. Applying this model to climate technology requires a similar shift toward open-source innovation, breaking down the proprietary silos that slow down carbon capture and renewable breakthroughs. Existential threats don't respect national boundaries. Solving them requires unified, open-source survival networks sharing every breakthrough in real time. If we apply that emergency playbook to climate change, our primary battleground is urban infrastructure. We have to physically convert our cities from carbon emitters into carbon sinks. We start with the buildings themselves. New passive high-rise structures use triple-paned windows and hyper-insulated walls, along with smart thermostats, to slash urban energy consumption by up to 70%. Then we connect those buildings at the community level using a thermal grid. Instead of every building generating its own heat, the grid physically captures waste heat from nearby industrial sites and data centers, routing it through a shared underground network to warm residential homes. Smaller infrastructure becomes active too. Smart roads generate solar power, while kinetic pavements harvest electricity directly from the foot traffic of pedestrians. To handle the extreme weather we've already locked in, we integrate bioswales and rain gardens into the streets to absorb sudden floodwaters and filter out pollutants. Hardwiring maximum efficiency into existing habitats allows us to maintain the functions of modern society while physically decoupling them from their carbon cost. If we project the successful rollout of these urban technologies forward, we get a different timeline for 2050. Success in 2050 is defined as near net zero, a state where the amount of carbon removed from the atmosphere matches the small volume we are forced to produce. Realistically, crucial industries like cement manufacturing and agriculture rely on chemical and biological processes that will always produce some greenhouse gases. This chart shows how we handle that. To offset the remaining industrial emissions on one side, we use negative emissions technologies, or NETs, on the other. By deploying direct air capture machines and mass afforestation, we scrub carbon from the sky until the system achieves perfect equilibrium. Long-term planetary survival is ultimately a math problem. We balance the ledger by actively removing whatever carbon we are forced to emit. The flooded, sweltering version of 2050 is not locked in stone. The 2020 pandemic demonstrated that when an existential threat is recognized globally, nations can mobilize resources and reorganize economies at a speed previously thought impossible. We already possess the physical technology, the scientific knowledge, and the collaborative blueprint needed to achieve a highly efficient, livable timeline. The point of divergence isn't decades away, it's right now. We simply have to make the active choice to execute the playbook and build the clean earth of tomorrow.